All right, so we're gonna start recording now.
Perfect.
So here we are. So welcome. I'll do my official welcome. Even though we've been chatting for a bit, this is my official welcome to CIT 225. Tonight we're going to talk just about the basics of this class, what to expect. We're going over data types because that's one of my favorite topics. We're going to go over that a little bit, and we're going to talk about the final in this class. So we'll talk about this. So every week there's a couple things required of you. There is exercises, which are basically just write this little piece of code and show me what you're talking about. There is an essay every week, which topics are basically trying to make sure you understand the concept for this week. So those are two. And then the third one is a quiz. And so those are the basic ones. All three required every week. So just be aware of that. Make sure they all get turned in on time. I'm going to say this on video, and I'm going to put this on the announcements. I do accept late work. I am very accommodating as long as you let me know what's going on. I have yet to have a semester at this university where someone didn't lose a parent. If someone got sick, COVID related or otherwise, if someone didn't get married, someone had a kid, we were all in this church. We all know the family nature of it. Something's going to happen to somebody. Just keep close to me. Let me know what's going on. And I have yet to not have someone make it through if they worked hard enough. So that's my guarantee to you. If you let me know what's going on, you'll be fine. Just keep up with the work as best you can. There is a final exam in this class. However, you may choose not to do it and instead turn in a final project. The final project is a capstone project for the course. What you're going to ask to, and it's on, if you look on week 3 is where it's first announced, but I want to let you know now so you can start planning on it now. Basically, you're going to be asked to design a back-end database for an application that may or may not exist. So what we were talking about before, Adam, you've already got the front end for the application you did. Now for your final project, you can design the back end database and do that.
I might actually just do that, and
Yep.
just because that's why I want to flesh out my app anyway.
Yep. So there's 3 parts to that final project. Is you've got to design an ERD, which is entity relationship diagram, which you'll see through the course here. What they look like is basically just a design of what the database looks like with tables and columns and data types and whatnot. You're also asked to provide the code to create everything, tables and indexes and whatnot. You're asked to provide the code to insert data into those objects, and you're asked to provide what's the word I'm looking for? Case studies on, like, for example, if you were doing a video rental business and you had tables for videos and customers and all that other stuff, you might want to find out what month most people rent romance movies, and you want to be able to write a query that says, we want to know who rents videos on romance, what month is most popular. So you write a query to show that. And so you're going to give me a case study and the query to prove your case study. And then finally, you just need to give a PowerPoint presentation or a quick video explaining everything to me. So that's why I tell you about it. Go ahead. Good question.
I was about to say, how extensive does this final project need to be? Are you looking for any kind of size or extent thereof, or are you primarily looking for the quality and context of this hypothetical?
Somewhere in the middle. App? Somewhere in the middle. We want at least 12 tables. 12 tables created. Okay. So, for example, if you're going to do the video rental business, the 12 tables could just be the inventory tables. The 12 tables could just be the customer tables. So, just pick a section of it and design 12 tables off of that. And as you go through the semester and I explain more and give you videos and how this is done, you'll see it's very easy. It might seem daunting right now. How am I going to come with 12 tables? It's actually pretty fast. 12 tables burns out pretty quickly. Also, okay, just so you know, if you do choose to do the project, I will make, we have every Wednesday night, I will be available to you guys like I am tonight for questions, going over things, stuff like that. But if you are doing the project, I will make myself available to you here and there. Just let me know what time's best for you. We'll arrange a video conference and we'll go over it. So I don't leave you straggling in the dark. I think this is something we just started offering last semester, and it's a really good opportunity for people who want to learn how to really get in depth to the design aspect of databases. So if you want to do it, let me know, and we'll make that happen.
Cool.
So this week, in your reading assignments, we're going to talk about what a relational model is. We're going to talk about what SQL is, what structured query language is, talk about the database management system, how to create a MySQL database, learn what the command line interface is, and about data types and table creation, stuff like that. So in this video here, I'm going to talk about a couple of things that are on this, not everything on the list. But I do want to point out, see, there are a lot of reading assignments here, and some of them are just like video tutorials or just odd web pages. Please make sure to go through all of these, because there's a lot of information that is not in the book provided. There's like little one-off information. And if you're used to MariaDB, or if you're used to Oracle DB or Microsoft SQL Server, Transaction SQL or T-SQL is the language they all use. Everyone speaks, all these speak T-SQL. But there are slight and minor differences between all platforms that catch you off guard. Like some things exist in some platforms where other things don't. Some data types exist in some platforms and some of them don't. So make sure you go through all the reading, take the time and go through, be familiar with it. The quizzes and final exam are all based on all the reading. So make sure you do that. All right. So first, let's start. What is a relational model? So we all know what a database is. A database is a series of tables that hold information, that allow information to be brought out and presented in a certain way. An Excel spreadsheet is a database. A Word document is a database. A piece of paper with stuff written on it is technically a database. What a relational database is a series of tables that are connected to each other through indexes and constraints that can query three-dimensional data. Okay. So if you had a spreadsheet for a video company, you'd have customer name, date, rental, all the videos they rented on like one spreadsheet. It's a big giant spreadsheet, like 500 columns long, 30,000 columns wide. And so we want, that's what you use. The old-timey spreadsheets were like the ledger books. In a relational database, we'll have a table for customers. We'll have a table for videos. We'll have a table for video orders. We'll have a table for every individual thing. And then what connects them are the queries that we write. There's something called normalization of data. And what normalization of data means is that in every table, the only data that's in there is directly related to what the table is about. For example, and this is just a lecture part of it, we're going to talk a little bit, I'm going to talk a little bit, ask questions, and in later classes, I will actually draw them out and show you how the connections are. So if we have a customer table, right, we have only customer information in there. There wouldn't be anything in there about what they rented. There wouldn't be anything about like their specific preferences. There wouldn't be anything other than like their name, phone number, address, date of birth, things like that, just information specifically about them. So that's part one. Part one is of normalization is we want only data that relates directly to the topic of the table. Part two of normalization is we don't want any redundant data anywhere. So if it's in one place, it's only in one place, never in two places. Okay. So go ahead.
You say you don't want redundant data anywhere whatsoever. However, according to the text, is there not extensible redundant data such as what was it? Certain keys that link across other databases?
Right. So with the keys, the data exists in one column. Like, so for example, what's a good example? So let's say we want to do the genre for the videos in our database, right? So okay. in the videos table, in the DVD table, we'll have a genre column, okay? But we might also have a genre table, okay?
Okay.
So the information, so there's gonna be a genre information in the table itself, but there's gonna be a table specifically for genre. But the difference is those are gonna be connected. So in the DVD table, I'm not gonna have horror, romance, comedy, blah, blah, blah. I'm gonna have a number. And that number is going to connect to the genre table, which has the actual information in it.
Okay.
So it's not, so redundant data would be like, I would have the name of the genre there as well as the name of genre in the genre table. I would have,
Okay. In other words,
right,
you don't want to have the same exact.
exactly.
I won't go to 2 or 3 or 4 different tables where I could find the exact same data I'm looking for.
Exactly. So like if you look in the
Okay.
orders table, we'd want the phone number of the customer, but we already have the phone number, their phone number in the customers table. So because the orders table refers to the customers table, we don't need to put the phone number in the orders table because we can just look at the customers table and find it.
In other words, each entity or object should exist once.
Yes, exactly. So we don't want that. That when we talk about redundant data, that's what we want.
Got it.
The third part of normalization is we want to make sure that the data stays clean. And what that means is we want to limit the ability of users to input important data as much as possible. For example, if we were inputting videos, new DVDs from an order into our database, we wouldn't want the customer to type out the employee to type out the name of the genre every single time because they're going to misspell it, right? So we want to give them a drop down. We want to give them a drop down menu. And again, this is just like a big overview. So we'll talk more about this in detail, specifically the drop down menu. But we want to give them a place to say, choose this genre and attach it to this DVD.
No freestyle, basically.
Exactly. No freestyling. We don't. The best application is one that does not require many text boxes. We want drop down menus. We want buttons. We want radial buttons. We want choices. We want the spinners. We don't want people typing stuff in. Okay, so that's kind of what a relational database is multiple tables that are connected that have specific information about the database that we link together to get the full story. And in my opening emails to you guys, in my opening announcements, I refer to databases as an art form. And I say that because data flows like water. And we want to make sure that we flow into the right place with the right information. And we don't want to give people a fire hose and drown them in data. We also don't want them to die of dehydration by just giving them trickle. Okay. SQL, structured query language, is just how we speak in SQLese. It is probably the most intuitive language that there is because the 3 main commands are select, from, and where.
Yep.
It's so much better than like C#, C++, where you get all bunch. It's like select information from this table where the data looks like this. You
don't like C out or C in and stuff like that.
Nope. Just select from, and even like you get with case studies and some other things that look crazy, but for the most part, it stays that simple. Okay. So the MySQL command line interface. When you run SQL, you're going to install something. When you install SQL at the road, you get something called Workbench. Use that. Don't use the CLI. Make your life easy. Okay. The CLI is like doing stuff through command prompt. It works. It's kind of cool. Understand how it does it. Right. Yep. But do it through the Workbench. Your life will be so much easier and you'll be much happier.
It's like Git.
Yeah, exactly like Git. Exactly.
Like, okay. You want to know how it works underneath the hood, but the GUIs exist for a reason.
The only time I've ever really done anything through a command prompt is when a manager was looking over my shoulder. And really? I needed to like make him think like my job was like, no one else could do my job. So I'd pop up the command prompt and do the stuff through there. And then he would go in, I'd go back to the Workbench. Okay. That's so funny. There's that. Yeah, sometimes you got to make your job look hard. Okay. So that's the basic. What I'm going to spend the rest of the time talking about tonight is data types, because data types are very important, more important than a lot of people think. So we're going to go over a couple different data types, specifically the numeric data types, the date-time data types, the string data types. The other ones are really kind of out of scope here. We're not going to really be jumping into those, but I want to talk about the numeric, the date, time, and the string data types specifically.
Isn't it because you want to make sure you're not using up too much, not too much data size?
Yeah, absolutely. Absolutely.
If we're handling databases, we're handling sometimes what, gigabytes, terabytes, petabytes worth of space.
And that's something, and you bring that up right off the bat. I mean, you're absolutely right. What a lot of DBAs don't realize is we're not only responsible for the database, the columns, and how the data flows. But we've also got to be cognizant of how big this data can get. And when we talk about this, the int data types here, you're going to kind of see this, because here's a little chart here. So let me back up for a second here. So there's numeric data types, there's date time data types, and string data types. Numeric data types are exactly that. They're numbers. They're not going to be anything but numbers. It'll always be numbers. There'll be some decimals, there'll be negative numbers, no imaginary numbers. That's only in algebra, and that doesn't exist in the computer world. But just numbers. Date and time is just that. It's just dates and times. The reason why they're a separate data type is because we want to be able to add 3 days, add 6 hours, add 2 years. So we want these things manipulated so we can like work them. String data types are anything. Anything that's on a keyboard can go in there. Anything that's not on a keyboard can go in there. If you know anything about ASCII commands,
Yep.
you can put hidden characters in there and drive people crazy. Don't do that. I'm not going to teach you how to do that, but don't do that. No invisible characters. I had a database once where someone had miscoded the database and put a hidden ASCII character in it. And every time it came up, it caused the application to crash. And we'd have to go searching for it because it was never in the same place. So
that sounds like a topic for computer security. You probably could create some very malicious.
Oh, you absolutely can. You absolutely can. And so that's interesting. A little digress here for a second. So computer security when it comes to databases is very interesting, because they're always worried about people coming in and like deleting tables or deleting databases or something.
Oh, it's more than just that.
They don't understand. You can go in there and make one small change that propagates through the system and ruin the database forever. I'm not going to teach you how to do that. It's just something to be aware of. Database security is a huge, huge field, particularly if you're if you have DBAs who go through cyber. So if anyone listening to this is learning the databases and then take on cyber, you'll have a very key job in companies keeping the data secure.
You probably work for some of the biggest companies out there because they want to make sure you're
absolutely. And the thing is, like, the company I work for is kind of falls on me for that, and I'm trying to train cybersecurity how to look for that. But it's really kind of an uphill battle, because when you're in IT, a lot of people are so stovepiped in the job, which means they only understand the confines of their job. DBAs only understand DBA world. Network admins only understand network admin world, and they don't speak each other's language. So if you have a very broad-reaching education, so if you understand, like, if 10 years ago you guys are going for Microsoft SQL Server certification, one of the classes you had to take to pass that certification was network administration. You had to understand how IP addresses worked, how firewalls worked, how routing tables worked. It had nothing to do with databases, but it had everything to do with how computers talk to each other. So you had a more well-rounded education. So if you as DBAs or as software developers, anything, understand the other side of things, you become much more marketable, because not only can you do your job, you can talk to people who do the other job. If you're a developer and you can talk to a DBA in the language they understand, you become very valuable. If you're a DBA and you can talk to the security team in the language they understand, you become very, very valuable. So that's digression one. Back to what we're talking about here.
So let's talk about. Oh, that's like going back to the data types. Isn't it like, I don't know how many of us would here have taken C++, because again, the catalog changed partway through a couple years back. But I know with C++, if you want to be mindful about memory usage, you have to be mindful of the data types that you're going to use: ints versus chars versus strings versus vectors.
Right.
And the same concept here is a bit to make sure you're using your memory effectively. I imagine the same concept applies here too. Tiny int, small int, or varchar versus char. You do take up so many bits and bytes, and since you're working with physical hard drive space,
right,
you don't want to use up more real estate than necessary. Am I following right?
Yeah, you're following exactly. So you got two things to worry about, because remember, data cannot be manipulated unless it's in active memory. You cannot manipulate anything on a hard drive. Anytime you need to change data, read data, you got to take it off the hard drive and put it into active memory. So not only does it need room on the hard drive, it needs room in active memory. So, and you bring up the exact point with data types. So look over here, you got tiny int, small int, medium int, and big int. Tiny int is 1 byte, small int is 2 bytes, medium int is 3 bytes, int is 4 bytes, and big int is 8 bytes or 1 bit, right?
Mm-hmm.
And here's the numbers. It goes, this is kind of off. Tiny int goes from 0 to 127, but also goes to negative 127.
Yeah, for signed versus unsigned.
Right. Yeah. So, and then going to here. So this is the thing. So they have it over here. Okay. So here's the thing. If you're going to have an ID, so every table has to have an ID column. So it numbers how many rows are in there. I worked for a company once that used small int, or was it medium int, as their
Default.
default for an ID column in the transactions table. Okay, so it was taking up 3 bytes per row. Okay, their table was something around. So this goes from 0 to 8,380,000. So their table was hitting the 8,200,000 mark, right? So that was using what? 2.4 trillion bytes, right?
That adds
So
up.
so that was taking up a big chunk of space on the hard drive, right? They changed it to big int. So it grew by almost 3 times. Because here's the thing.
Were they expecting to get to that amount of
when they started the company, they didn't think they'd pass 9 million rows in that table.
Oh wow.
So they completely miscalculated. And so 10 years in, and I was working there for 2, they were very close to this number. Now here's the thing. When you create a table and you have a column there that is an int or tiny int, when you create a row, it takes up that much space. So if you create row with a tiny int there, every row takes up 1 byte for that column, no matter what you put in there. If you put in 1, 15, or 120, it still takes up 1 byte. If you create with int, it could take 4 bytes per row, regardless of what you in there, 1, 15, or 2.4 trillion, 2 trillion. It takes up that size. So at that point in time, every row of those 8 million rows took up 3 bytes. When they changed to big int, that column, every row then took up 8 bytes.
So they had to actually physically install more hard drive space.
They had to move the database to a larger drive, because it went from, if I remember correctly, it went from like 850 gigs to 2.6 terabyte.
Okay, so might just be academic at this point, or just kind of move, because I don't know the company's points. Why switch it to big int? Why not just go from medium int to medium int unsigned? Why would you want to extend all the way down to minimum negative values?
That's a really good question. So why would they go from medium int right to big int? Okay,
because I mean, why waste on values of negative numbers on IDs? Because I don't know, that doesn't make any sense.
Well, it's the unsigned values. This part here isn't really what's important. I mean, it can go either way, right? But the fact they were going from a top number of 8.3 million to 60 gajillion, whatever that big number is, to the 60 to the power minus 1.
Oh, sure, that's fine. I just wasn't sure if you're actually literally saying that they switched from medium int. I was like, why not make it unsigned? You could probably just get.
No, they went from medium int to big int. They went from medium int to big int. They jumped from this. So what we did is we altered the table, because when you create a table, you can create an alter table command. So we alter the table and then change the data type from the ID column from medium int to big int. It took, so the data, like I said, the table was like 800 some odd gig. It went to 2.6 terabytes when it was done. It took 7 days to complete the operation.
Ooh.
So you do pose a good question. Why would they just go to int? Why would they jump to big int?
Were they expecting were they projecting a large
So here's the thing. They're looking, in 10 years, they hit 8 million. So they were growing
exponential growth.
And they had shown exponential, because when I did the analysis on it, they were showing exponential growth. They were growing 2 to 3 times the number of transactions every year, because it was a property management company. And I'm not property management, it was the people title, sorry, it was a title company for real estate. And every couple months they added a new county and more people were searching. So they had started with 10 counties. After 10 years, they were like at 300 counties, and every county brought X amount of transactions, X amount of everything. So I projected out that in another 10 years, they'd be getting pretty close to this. So they said, let's just bite the bullet once and do it this way.
So that's two to the power of 63 is we're hitting like over 9 quintillion.
Yep. So it would never go. And so and then you got to look at yourself. It's true, but then you look at it like, you know, if we might hit, so what's this, 2.14 trillion or something like that? Was that just one? There's three. There's three. So this is 2.1 billion.
Yeah.
So if you hit 8 million in 10 years, you know, and you're growing, this company is growing like 5 to 6 counties every quarter. And that was bringing in 1.2, 2.7 more transactions per month. You know, you're going to start growing and growing and growing. Sometimes you got to look at it and say, you know what, this might seem ridiculous to go this high, right?
Sure.
However, what's going to be more painful? Getting the storage now to meet this, or having to change from this to this in 6 years?
Fair enough. So they're like, let's just bite the bullet, go big.
Yep. It's on a similar thing. Like when I worked I used to be a public school teacher, and they were building a new school, and they built the school to house 2,500 students. They knew opening day enrollment would be 3,500 students, but they still built it 1,000 short because they said, in their words, it was less expensive to modify a school than it was to build a bigger school initially. So they chose the other way to do it, which never made sense to me because they didn't take the intangibles into play, like the stress on the students, the overcrowding the hallways, the stress on the teachers, but they were looking at dollar amount. Companies in IT sometimes look at the stress because they had to take a 7-day outage to fix that data type. And customers were affected big time, and they lost a lot of that money and time, but they had to do it, you know? So sometimes
basically, the latter option sound like a bunch of bean counters not really paying attention to the students' needs. So yeah,
exactly. And that's the same thing in IT. You will run into management says, well, we can't afford 7 days downtime, but then you say, okay, it's 7 days downtime now, but in 6 years we're going to take 2 weeks downtime, and they're like, okay. So
so you kind of have to really put it down to bring it down a notch for them to understand, right, kind of thing. All right.
And had someone at that point in time, when the table was made, said, you know what, we're just going to go with int, they may have been safe. We're just going to go with big int. Sometimes you don't know. If you're like with a small company, like you're in a mom and pop store and you're selling popsicles to kids, you probably wouldn't need to go much bigger than maybe medium int, probably not too small int, you know, just tiny little things because you're doing a little database. But when you're in a big company and you're expecting millions of transactions a year, you know, you got to really.
I imagine banks have large databases such as like using big int and stuff like that.
You want to talk about the one database that I've always wanted to get my hands on is the church's genealogy database.
Ooh, actually, that's a good point.
Yeah. Can you imagine how much information is in there?
A lot.
Terrifyingly enough, right? Because every genealogy site uses our databases in the church.
Ooh.
That's why we get. That's why we get free Ancestry, we get free MyHeritage, everything, because they're using our databases. If you're a member of the church, they're using our databases, so we get in for free.
That's funny. Interesting.
So anyway, so when you're choosing your data types, you know, kind of think, how big is this? How big is this application get? How big do it perceive? You know, how do I perceive this growing? And then choose the data type based on that. Particularly when talking about numbers, because you know, like these numbers is 0 to 127. I don't think anything else should ever use a tiny int, unless you're doing like even a zip code, because zip code should always be chart. We'll get into that in a second. But like anything that's going to go above 127, maybe age would be good for a tiny int.
Well, maybe for now, but I mean, put it down and maybe, I mean, depending what it's going to look like in the next like few decades.
That's true. Absolutely.
The age, it's ready to get higher than that.
Yeah, absolutely. So, you know, so it's hard to find something that used for tiny int. Even like inventory, no. But so when you're choosing data types, like for numbers, be very cognizant of how many columns you think are going to go in there. You know, maybe like you might use tiny int for a genre table because there aren't 127 genres, or like a ratings table, like there's only 8 or 10 ratings right now. So, you know, just be very aware and choose the right one. Go back here. can I go back here to the one I was, so that's int. So then we've also got decimal. So
Numeric.
decimal, numeric. So decimal has these two numbers here. One is how many this number is how many places after the decimal that you want, how many places in front of the decimal that you want.
This is where you store floats, right?
Yep, and then floats, that's
Yep.
floats are in there too. So this is like the where we start getting decimals and things like that. And then numeric is also one that becomes more of a broader, like not whole numbers, like decimals and more fractions almost in there. I apologize if you hear my dogs barking in the background. They must see something outside. So yeah, so and then float and double. Again, I'm not gonna go deep dive into them, but read about them so you understand where to choose what. In Microsoft SQL Server, there's one called money that specifically deals with the money and how money works, which is really kind of cool to play with for like a cost. In here, you'd probably use decimal for money. Bit is just that. It's one or it's binary. It's binary. It's Boolean. It's yes or no. It's 1 or 0.
I'll do it.
Yep, that's a good one to use. Let me go. So let me go back over to here with date and time data types. There's 3. There's date, time, and timestamp, and there's time and year. So all these different data types, you want to use those for like birthdays, dates of purchase, stuff like that, because you want to be able to manipulate them that way. We want to know, you know, when something was bought and how many days ago it was. Like shipping tables, you know, date of purchase, we add 10 days to it. So if you did like a date time data type and added 10 to it, it would know you meant by default 10 days. So make sure, like when you have columns like that, you know, date time, make sure you use the date time data type. And then string data types, there's var and varchar and binary and var. So let's talk about these char and varchar. The difference between char and varchar is if you char and varchar are followed with a number. So let me get over here. So we'll have like char 4 versus varchar 4, right? And this table is great. With a char 4, if we say char 4, no matter what goes into that column, 4 bits is going to be taken up, regardless. So if I had char 15 and I put the letter A in there, it's still going to take up 15 bits. Okay. If I do varchar 15, and as you can see here, if I put the just blank in there, it's going to take 1 space. AB takes up 3 bytes. ABCD takes up 5 bytes because of the quotes. So that's what it is. But everything here takes up char 4. That's it. Okay. Everything's before. Everything here is going to be variable based on what's going here. And look, and this is important here. You see this? If I try to put an A, B, C, D, E, F, G, H, all that's going to go in is A, B, C, D. It'll be truncated. So if I've got a char 4 value and I try to put something big in there, it's only going to take the first 4. And then we've got corrupt data.
So why use one over the other?
So that's a good question. So why would I use one or the other? So in most systems, and here's the difference. In a Oracle or Microsoft SQL Server, if you do char 2 and try to put anything bigger than char 2 in there, you're going to get an error. It's going to say, hey, you're going to truncate these values. We're not going to put this in. Okay. In MySQL, it doesn't care. MySQL is just blank. Sure, I'm only going to put the first 4 in, but I'm not going to warn you that's what I did. So why would you use a char 2 versus a varchar? So if you're doing a state, if you're doing states, you want a char 2. Okay. If you're doing
a very fixed amount.
Yeah. If there's something where it's going to be a fixed amount and you want it to error in there, then you'd use a var. But like for like last name, you'd never do like char 15 because you get like 1 Rabinowitz and that's it.
Or
right?
like, so you want to do like I don't know, iColor for state IDs.
Sure.
Just something that has something there's like a standard by some company that you have to. Okay.
Like let's say like you're even if you did like an ID, you never know, you might have to go. Right now you've got a 6-character ID, but if that has only X amount of combinations, so you might need to go a 7-character ID at some point in time. But like if you had anything that was like, it's always be like a zip code will always be 5.
Sure.
So you put that in as a 5. A social security number will always be 9. So you put that in as a char 9. as opposed to, because it's not really numeric. A zip code isn't numeric, and a social security number isn't numeric. It's a char thing. So
Really?
that's, yeah. Yeah, because you never add 6 to your social security number.
True. Fair enough.
Yeah.
Okay,
And-
so why use char versus string in that case?
So string is being deprecated. So we
Really?
don't want to
Okay.
use that one. So we want to, and even if it wasn't, char and varchar are universal. Everyone uses those. Not
Oh.
everyone uses string.
Okay, again, this is my C++ coming back out of
Yeah.
here. So
Oh yeah, so that's a whole different thing. String in C++ is something that's in the programming language. So strings convert to varchar.
oh, okay. So what the heck is string in SQL?
Varchar. Well, okay, so string can be a couple things. Depending, so string doesn't have a limit on how big it gets, right?
Sure.
So as
It's a data structure technically.
right. So it could be a varchar, it could be a char. It could be a text. We're gonna get to those in a second. So that's when you, as the DBA or as the developer, got to say, okay, this is going to be a last name. It's being brought in as a string, and we're gonna have to convert it to this data type in the database. And there
Okay.
will actually have to be a conversion in the SQL query to convert that data to the content of what's going in, unless it's going into a text.
Well, a lot of there are APIs that exist already, as
Yeah.
mentioned in the text, depending on what kind of language you're using, like C#.
Yeah. Well, actually, if you're doing it the way that's you should be doing it, you're going to have the C# code or C++ code call a stored procedure in the database and pump the data through that into. You don't want the code sitting in the application for SQL. You want a stored procedure, data being pushed into the stored procedure, so SQL can input the data its own way.
Stored procedure. So you're talking about just some kind of like just custom written function?
Yeah. So a stored procedure is just a SQL function.
Oh, okay. So
But
you call the function, throw your data into there, and there you go.
Yeah, basically. But
Passing the data. Okay.
Yeah. So we use the term stored procedure in databases.
Okay.
So it's a procedure that's parsed, and just put the data in and it just runs its own. But it's technically a function.
Okay.
Or a
It's
code.
just want to make sure I understand it from a developer's perspective. So it's basically a function you call, passing your information, and it just
Yep.
calls appropriate function in SQL. Okay.
Yep.
That makes
And
more sense.
so since I was a C# developer at the same time as a database developer, I speak both.
This is our going back to our early conversation of understanding multiple languages in the field. Absolutely.
Okay, so char versus varchar, judgment call. What are we going to do? If we know it's going to be X amount, if it's only ever going to be this big, we'll use char. If we're not sure how big it's going to get, we're going to use varchar.
Got it.
We've also got the binary and var binary. So, and then the blob and text. So binary and var binary. It's not necessarily for binary or var. It'll take hexadecimal into there too. It's for encoded stuff.
Why var binary? If binary is only like one or yes or no, what the heck is var binary?
No. Boolean and bit are yes or no. Binary.
Oh, my bad. Sorry.
Yeah.
Okay.
Binary can go. So in binary also is hexadecimal.
Oh, got it. Okay.
So it's when you have like this big encoded stuff in there. So again, like binary. Yes. So binary could be one or two position, like 0, 1 or 0, 1, 1 or whatever it's going to be. So you can put it in there as that. And you can do binary 5, binary 6, whatever it is, or you do var binary and then whatever the size is. You can also, by the way, in the var binary, you can do var binary or varchar max, which means as big as it needs to get.
So would I use just a binary 6 just for to store colors? Because I think hexadecimal color coding only has 6.
Yeah. You can use binary 6. Yeah.
Or do binary 6 for that.
Yeah.
Okay. So that's where you use that for. Okay.
Or you can use varchar.
So why do we use?
So here's the thing. So there are all these data because these have been around for a while, like blob.
So this is basically legacy support.
Yes.
Okay.
So we're talking. So the next ones are blob. I'm not going to talk about enum instead. Don't worry about those, because those are being deprecated. No one uses them. Don't ever use them. Your life will be easier. Blob and text.
Even though the textbook mentions it.
Yes. Know what they are. Answer the questions. Well, this isn't the textbook. This is my own website that I go to. Not my own.
Oh, sure. Yes.
This is my SQL website. It's just easier for me to get the data types from here. So blob and text are like, I want to take a, so blob was specifically for storing photos in a database. So it's blob
Okay.
data. It's all hexadecimal encoded and stuff like that. So it just takes a bunch of crap and jams in there.
Hence blob. It just
Right.
has
And
an amalgamation of everything.
right. So, and text is the same thing. So let's say someone wanted to put like, you know, Nephi 1 in a database. You put it into a text. Into a text. So a text has no limit in size.
So it's like a block quote for JavaScript
Basically,
or HTML.
yes. Yeah. So here's
Okay.
here's the problem with the way this works. And there's a video I'm not gonna post it because this is kind of a deep dive into this, but data when it's stored on the drive is stored in 8-bit pieces. Okay. And anything that goes over a certain amount is stored somewhere else. So if you cut and paste, into a database, into a text file, into a text column, and put, I don't know, 8,000 characters, it causes, it's searchable, it's fine, but it is slow as snails. Yeah, molasses. Yeah, sure. That's a good one. I was dragging there.
So basically, this sounds like I need to defrag the freaking heck out of the database. Sounds
correct. Like and actually, I have a video about defragging and why it happens and all other stuff. But so blob and text are being deprecated across the board. And now when I say deprecated, it means they're telling you not to use it anymore. It's never going to go away because they can't, because they've got all these legacy systems that's not being updated and blah, blah, blah. So it'll always be supported, but they're saying, please stop using this.
So basically we're trying to make it a cultural norm in the database management system,
correct,
society to make this bad practice. Do not use blob or text.
Correct. We only really want to use this, char and varchar, because varchar max does the exact same thing that text does. It just does it better. Var binary does the same thing that blob does, just does it better. But we don't want to store pictures in our databases. We want to do something different, and that's a whole other conversation.
Got it.
So we just want to use this.
So
we need to know what these are. And because whenever I start a new job or whenever I consult on a database, the first thing I do is I look for blob and text data types and immediately change them to varchar.
Got it. And now this is just kind of a side note, since we're talking about like defragging hard drives and whatnot. Is this a bigger issue if we're actually using like spin disk drives? I don't know what the actual physical makeup of like most databases actually look like. I don't know if it's effective to use solid state drives or if that's even economical.
Oh, it is absolutely. You want to do it, and like I said, how these things work is not within the scope of this class. However, sure, it is a topic that I love to talk about. I'm just not going to do it tonight.
That's fair.
But I have a video. Yeah, and I have a video explaining how this works in detail. And one Wednesday night, I will go into detail and have this conversation. But suffice to say, the way data is organized on a drive, it's whether it's solid state or spin disks, it's still stored in 8-byte pages that are combined into 8-page books. And just leave it at that. We'll get into more detail, but yeah. So in 64K, they're invested in 64K blocks.
Got it.
Okay, so that's what I want to talk about tonight. I want to talk about those data types. There are other data types too. All this about creating databases, all this stuff. I've got a video I'm posting there on that when this goes up about the DDL languages, the commands. But I wanted you to get an idea of the data types that we use, why we use them, and just how to be really cognizant about which data type you choose. Sure. And when we go through the design, if you guys choose the design versus the final exam, when I look at your ERDs, I'm going to ask you, why did you choose this data type versus this one? And we're going to kind of walk down those paths. Okay. So I think that covers it for tonight. Jacob, you came in late. Do you have any questions or anything you want to ask? Or I love your old school test pattern. That makes me feel old and happy.
Sorry, I came in as late as I did.
That's okay. No worries.
Mixed up.
Yeah, I know.
My question is would this recording be posted for everyone to see at some
Yes,
point?
yes. What I'm gonna
Okay.
do is I will, because I record through Zoom, so it takes 20, 25 minutes for it to convert to an appropriate format. And then I post it to YouTube, and then later tonight or tomorrow morning, I'll post it to an announcement.
Okay, perfect. Thank you.
Yeah,
Appreciate
so everything will be covered. So yeah. Yeah, that's why I think I bolded out EST, because I am in Florida. And I know everyone else is like, usually everyone else is like in the West, so you're 2 hours ahead of me. That's why this semester, I'm doing it at 8:30 and it's supposed to 7:30, because last semester I did it at 7:30 and everyone's like, I'm just eating dinner. So I did an hour later, so it's
Oh.
6:30 for everybody.
That makes
Um,
sense.
Yeah, yeah. So we have students in South America and in Africa, so we got time zones all over the place.
Yeah, I was in a class one time when I had me here, East
I'm gonna head out
Coast
then.
class.
Thank you.
All right.
See it. Me here, classmate in Mountain Time, another classmate in Pacific Time, another classmate in South Africa Time, and that was really hard to get everyone connected at the same time.
Yeah. Yeah. All right. So if there are no other questions, then we're gonna call this done. And keep in touch, get stuff done. If you have any questions, make sure you email me or text me.
Cool.
Thanks, everyone. Thank you.
Thank you. Bye.
Bye-bye.